I'm not native speaker, so okay, I make many errors for sure. And so, okay. So if you want English course, then you have to go to the modern language service of our university, and there are many courses there. Some of them are related also to publish a paper, but okay, they put more emphasis in English, in the grammar and all these things of English, and I will put more emphasis in the path from the beginning to the end. So there are different courses, but of course, here, unfortunately, you will not learn English. Well, maybe a little bit, but not. It's not the objective of the course, for sure. Okay, so these are some books that I have used and also some references in internet that you can find them in internet that I have used to write these slides. So then you see here there is a warning saying that, okay, in some cases I simply have copied the sentences from these sources. So I am committing plagiarism. I will tell you that you don't have to do that, but this is not for publication. So it's not, let's say, so this is just for, let's say, exchange ideas among us, not for publication. I will not publish this. So this is not, I think I'm not committing something that is unethical, let's say, yeah? Because simply is material to discuss among us about this process. Okay, this is more or less you see the structure of the course, three parts. Writing in science, this is what we are going to discuss today. And it's in general, the general ideas about this, the situation of writing English, or the problems that you can face in this field. Then we will um, focus on a structure of a scientific paper. So this is probably the, let's say, the most important part of the course. And finally, we will also go along the submission, review, and publishing processes. So this is the idea. So you know that the classes will be from today, next Wednesday and Friday, and then Monday and Wednesday of the next week. All of them will be here from 3 o'clock to 5 o'clock in the afternoon, and the classes are retransmitted by streaming. Yeah, so there are some people that are, let's say, registered to the course, but they cannot attend the course, but they will follow us through streaming. Then what is how I will evaluate? So basically the marks are pass, no pass. So it's very simple marks, but they ask us to evaluate you, the courses, let's say, and I will ask you to read this paper, and okay, I will make corrections. Yeah? Then I will ask you also 80% of assistance. So I have, these are, let's say, okay, to control the assistance. So you simply sign. So today is Monday 6, so you make your signature here. And okay, this is the proof that you have been here. So, okay, if you want to start, you can sign it. I will take with me these papers. Okay, then what is the deadline? So I put 14 June. Okay, if you ask me, okay, we need one more week. I mean, no problem. For me, it doesn't matter if it's 14. I just put one day because, okay, we have to put a deadline. Right? But let's suppose that next Wednesday you say, okay, we would like to have more time. I think this is for 1 month, more or less, from the 15th, from the 15th to the 14th. So you have 1 month to write. I think should be enough. But okay, if you need more time, just tell me and we can change that. Okay, if you, I don't know, if you are using Twitter, but in case you use Twitter and you want to write something, I suggest this hashtag, and okay, this is my Twitter. And you will see that in some slides I put this symbol, and this means that, okay, I will not comment this slide, but you can, maybe at home, you can read it, and maybe if you want, we can make some comments here, we can comment something, but in principle, it's something to read at home. And then I also ask you to choose one paper and bring the paper to the class. So in some cases, we will read the paper, okay, you will read the paper, and Maybe, for instance, when we discuss about the abstract, we will discuss the structure of the abstract, and I will ask you, okay, take your paper and look if the abstract has the structure that we are proposing. I, hello. I have to say that, okay, writing is an art, it's not science. So there are some rules, but okay, they are, let's say, approximate rules. I mean, they have not necessarily to be fully fulfilled. Simply, okay, it's an art, so then you are the artist and you can make changes and not follow exactly what I will tell you, but okay, in principle it's good to have some reference, and from here, if you want to make changes, you can do it. Okay, so, oh, by the way, let me go, yeah? Oh, yeah. Okay, this is the, okay, I have to use microphone because of this stream. Yeah? This is the Moodle of the course, and here, if you go there, you have the slides using the course, so you can download there. You have the template for the communication. You can use this, or another one is simply a suggestion. You can use this template for the communication, I mean for the evaluation part. And then this is to submit the communication, right? So once you have write the communication, you can submit it through here, right? This is the idea. So there is nothing more. It's just very simple. There are three topics, basically. And okay, you have here all the slides. So if you go here, I guess you can download, and you have the slides in PDF. So it's that way. Okay. Okay, let's continue. Okay, so this is the first slide. And you see, I mean, I don't know if you like football or not. In my case, I like it very much. And this is a trainer who was very famous in the 70s, or a little bit 60s, 70s. It was a trainer of Liverpool at the time that Liverpool was good. Now it's also very good, but before it was even better. He had several European championships he won. And he wrote, "Some people believe football is a matter of life and death. I'm very disappointed with that attitude. I can assure you that it's much, much more important than that." Okay, this is what Shang, this trainer, said. Okay, it's quite a famous sentence. And I wrote this because in this paper, in the paper that I told you before, so this is this one here, the book on how to write and publish a scientific paper, there is a sentence which is taken, is quoting this sentence by Shanky and say, good scientific writing is not a matter of life and death. It is much more serious than that. So, okay, it's taking the same idea. That's very important. Okay, we have also another, this is from this PLOS computer biology. By the way, I am chemist. My name is Mikkel, so I am chemist. So most of the let's say examples comes from chemistry, but okay, they are useful for any I mean they can be extrapolated to any subject of sciences in general. Right? This one is not, it's for biology, computer plus computer biology or something like that. Good scientific writing is essential to career development and to the progress of science. So some years ago we said this, you probably have heard that, publish or perish. This is something that unfortunately is quite true. And now you probably you go a little bit long, you go a little bit farther, and you have to write be found or perish. So it's not only writing, but also to be cited. Yeah? So other people has to cite your works, because in that way they show that the work is interesting, and so this is how more the science is evaluated, in many cases by the citations. So it's good to have as many citations as possible. So get cited or get ignored. So we should try to get our paper not only published, but also to get cited. So this is something that we have to keep in mind. Okay, this is a editorial from this physical chemistry journal, Physical Chemistry Letters. Okay. By pressing here, if you want, you go directly to this editorial and you can read everything. But I want to emphasize this paragraph here. Writing skill matters. Good writing skills are an integral part of a successful research career. So good writing skills are an integral part of successful research career. So okay, we have to acquire these skills. It's part of, during the PhD, you have to finish with the ability to communicate research by writing good research. So this is good research papers. Okay, this is another editorial by Nature, this one, the past, present, and future of PhD thesis. Okay, there are many comments here, but I extracted this one here. The goal of a PhD assessment everywhere remains, rightly, to demonstrate that the student has conducted and can communicate independently original research. So at the end of the PhD, right, one has to have this competence. One has to be able to communicate the research independently. So alone, let's say, without the help of other people. And there are some, this is a group of, let's say, people in Europe about, they discuss about education and education in the bachelor, in the master and PhD, and they attribute different competences to each level. And in the case of the PhD, these are the Dublin 24 descriptors. They talk about the PhD competences, and one of the competences is can communicate with their peers, the larger scholarly community, and with society in general about their areas of expertise. So the possibility, there is a need to communicate, and okay, you have to learn how to communicate, not only papers, but also in general, with society. So also for the outreach, let's say. So we have to be able to communicate our research to people that is not specialists in the field, both to specialists and non-specialists. But okay, here we will talk about communicate research to specialists, so about writing papers. Okay, and this is a little bit history. So the first paper appeared in 1665, at the same time in London and Paris, in these journals. And since then, the size of the published papers has doubled every 15 years. Double. Every 15 years, there is a double of papers. Okay, there is some graphical here that show that every 15 years is double. Is doubling the number of papers that appears in the literature. So in 2018, was about 5 million papers were published. So it's a lot of papers. And this is about my field of research. I'm working with one phenomenon which is called aromaticity. Right? If I put the word aromatic, and with this asterisk means aromatic, aromaticity, I don't know, anything related to this word, and I look in this Web of Science, I will show you this Web of Science, and I look at how many papers were published in 2018 with this word, you find this number. So almost 16,000 papers, right? If I have to read everything related to my field of research, I need to read 1.8 papers per hour, so almost 2 papers per hour, without sleeping, without weekends, anything. So just for reading everything. So it's impossible, right? It's simply impossible. So what we do, and for sure you will do the same, and your bosses, your supervisor are doing the same. They select some papers. They do not read everything. It's impossible. So you select some of them, and we have to be aware that, okay, we want our paper to be one of the selected papers, right, by people, if possible. Okay, so this is another data. We are about 7 million scientists in the world that we spend $2.3 trillion, I think trillion in the American meaning of trillion, to generate new science and publish over 4 or 5 million scientific articles every year. So of course there are people read more papers than science. Okay, so this is about, okay, this is another database of papers. So this is the Scopus database, and this is showing how many papers were published along the years from 2010 till now. Okay, of course this year, this was probably this picture, I take this picture in January maybe, so it's still about 1 million, but you see, It's increasing. So this was in 2010 more or less 3 million. And if you, I mean, you think about what could happen in 2013. So no, 2025. So 15 years after the 2010. So in 2025, it's quite likely that the 6 million will be reached, maybe. I mean, it's something, it's just prolongating this line. So it's what I told you before. Every 15 years, there is the number of papers published is doubling every 15 years, more or less. So now we are about 5 million papers published every year. It's a lot of papers. And the risk is that there is a sea of papers here, and okay, my paper is here, and nobody notices that my paper is there. Nobody cares. And okay, I also read this. This was in Twitter. So if you go to Twitter, and I recommend you follow this Científico en España. It's quite funny. Well, depends. I mean, it's funny, but it's serious at the same time. It's both. And they publish this Twitter, and they say scientific Diogenes syndrome. So what this means? This means the syndrome that many scientists have. I have it for sure, and I'm sure many of you supervisors have, that to collect papers, okay, I have to read that, and then you are going to you collect the papers, and you have something like that in the desk, but okay, some of them they are not never read, because it's impossible. But okay, you feel the necessity to write to collect these papers. If you have time, you will read them, but okay, many cases you don't have time, and you don't read them. So this is this Diogenes, the syndrome. And okay, it's something quite common, I would say, among scientists, to collect papers. I will read this in holidays, but okay. So, okay, something just is your aim, but in many cases is not fulfilled. Okay, so I will not I will not go to all these papers, but if you want to go, just press in the PDF file, you press here, and this goes to a paper discussing el drama de escribir papers para casi nadie. Yeah? So it's related to this fact that there are a lot of papers published, so some of them gets unnoticed. Okay, and this is what happens this is about citations. So in 1980, so this is something that is reducing. Yeah? So it's good news here. So the number of papers that nobody cited in 1980 was about 20%. And now this has reduced about 10%. So the number of papers that are never cited by no one is being reduced along the years. But still, there is a significant number of papers that is not cited at all. So they do not receive any citation. And you see how more or less this goes. So this is in 2010, papers published in 2010, 40% of these papers has never cited at this moment. Yeah? But maybe it will be cited in the next 2 or 3 years, who knows. But this is the way. And you see that it increases, of course, number of papers cited. Published in 2019 is a lot, is almost 100%, but this is because, okay, they have just appeared, so it's not, they cannot receive citations after let's say, 1 year or 2 years or something like that. So there are science that has never been cited. This in principle, if it is not cited, is because maybe it's not so interesting, let's say. Okay, so you have here the proportion of papers attracting 0 citations is 80% in chemistry at this moment. Okay, but it depends on the field, of course. But you see that around 10% of the scientific research papers are never cited. Okay, and this is some ideas about science. Science is a collaborative project, so all of us contribute to the scientific knowledge. And it, in general, I mean, in some cases there is kind of revolutions, right? The quantum revolution or the revolution related to relativity or this kind of thing. But in general, it doesn't advance by great leaps, but by small steps. All of us are producing new science, and this is becomes part of the, let's say, corpus of science, and this is how science advances. And the key word is reproducibility. So our work has to be reproducible. This is, I think it's important to note. I mean, if you perform a scientific experiment but you don't publish the results, this is not science. Maybe this is very strong to say that, but if it is not part of the common scientific knowledge, so uh, everyone can access this knowledge and use it, then it's not science. It's simply, well, it's maybe, well, it's something that you have done by yourself and you have this knowledge, but this knowledge is not science because it does not belong to all the scientific community. It's only science when it is, let's say, disseminated. It's shown to the rest of the community. And this is a professor that came here for, I think it was the 12th Girona seminar, I don't remember now, Lai Sheng Wang, and he said that results not published equals experiments not done. And he told us that he has a lot of spectra, but okay, he has not been able to explain everything. So okay, these experiments are not science. So they are there waiting for someone that makes the, let's say that explains there, or usually the kind of science that this professor does is, okay, he has a laser beam and he makes strange molecules and he can record the, what is called the ultraviolet or violet, visible spectra. And with this spectra, they can, if they have, let's say, theoretical results, by comparing the experiment and theoretical results, they can decide which is the structure of the molecule. So he has, according to him, he has a lot of recorded spectra, but without interpretation. So without that, he does not publish the work, and if not published, not science. This is what he says. So an individual's knowledge, so this is what you get. You have individual's knowledge if you perform a scientific experiment, enters the domain of science only after it is presented to others in such a fashion that they can independently judge its validity. So only when it is published, it becomes science. Before, it's simply an individual knowledge. So a process project is transformed into scientific knowledge only after being published. By publishing it, research is authenticated and then added to the existing database that we call scientific knowledge. So then it becomes science. And publication is important because it prevents each generation from being condemned to having to rediscover the wheel vaccine of human rights. So without publication, okay, every time we should start again. So, but in that way, all knowledge is accumulated in the scientific knowledge, in the journals, and this can be used by other scientists to advance in science. So this is the idea. Definition of scientific paper as a written or unpublished report describing original research results, or a selection of data and its interpretation represented as word or images to deliver a scientific message or messages, principle one message, but okay, maybe it could be several messages to a particular audience. So we should have a message. To have a paper, we should have the message, the data that proves or gives credit to this message, and the audience, someone that reads it. And as a scientist, we are professional writers. So we are, as a scientist, we are many things. We have also to take care of money, so we are economists. We have to take, I mean, many things. We have to deal with a group of people, so at a certain point, we have to be a little bit psychologist or whatever, but also, this is very important, professional writer. We have to write good papers. And writing is an art, not a science. I cannot tell you how to write papers like I could explain maybe students about, I don't know, for instance, to solve differential equations. It's another thing. So this is an art. And as an art, it is acquired by imitation and practice. So the way we acquire this art is reading papers by other people that write good papers and then practicing. And this means writing first drafts in the case of PhD students. So I don't know what is your case. So it depends on the supervisor. But sometimes supervisor says, okay, I will write the paper. Other times supervisors say, okay, you write the first draft and then I will make corrections. In my case, I prefer the second option because it's the way, by writing, is the way that you acquire this competence. If it's the supervisor that writes the papers, then the PhD student finishes without knowing how to write papers. I think it's good for you to ask the supervisor to write your papers, but okay, this is up to you. The watchwords, so the keywords in these writing papers, in scientific writing, are clarity. So clarity basically means that there is a message that you want to deliver to the audience, to the readers. And it should be clear, the message. If you have two messages, it's okay. Three, probably it's already too much. More than three, it's for sure too much. Then it's better to split the paper in different parts. Better if it's only one and clear message that you want to offer. Brevity, this is also important because scientists usually read scientific literature for information and not for entertainment. The people is not looking for fun when they read papers. So it should be brief as possible. This is important. Clarity, clear, brief, and organized. Everything organized. So, okay, we will talk about the organization, the structure of a paper. So it should be following the usual rules. Abstract, introduction, method of calculation, I don't know, whatever. But writing can, and often does, prevent or delay publication of good science. If the paper is not well written, probably we will fail. When you submit the paper, it will fail. It will be rejected. So it's good to try to write as good paper as possible. And okay, I mean, in your specialty, I'm sure that you can think about someone who's very good in your specialty. In theoretical chemistry, for instance, I think I can think about Roald Hoffman, Gernot Franklin. There are many people that are very good. And all of them, they write exceptionally well. You'll see. I mean, it's very difficult to be a leader in a scientific field and write bad papers. This is not possible. It's not. So all of them write exceptionally well. So if you have these people in mind, I mean, use these people, the papers of these people, to learn how to write good papers. So this is a good advice. You have people that write exceptionally well. So then use them, use these papers to also to learn how to write good papers. And okay, you have this, the clearer one's thinking, the easier it is to convey one's message. You have usually one message, so if it's very clear, then it will be easy to write everything. So, let's say to give evidence that prove that this message is correct, for instance. So there are two possible ways, and I think they are either to write clearly, you must first think clearly. This is probably true, but also the other one is true. Clear thinking can emerge from clear writing. If you are trying to make good sentences, clear sentences, sentences that are clearly understood by readers, then you also have to think clearly. So there are the two ways. So by writing clearly, you also learn to think clearly. And once you have clearly think what is the message that you have to give, then you can also write a clear message. So I think, well, it's in the two directions. It works in the two directions, one direction and the other. And good, clear, and precise writing emerge from a process of struggle. It's not easy. I mean, it's something that it takes time. So, okay, we have to use time. And okay, this sentence by Ernest Hemingway, it is true. Easy writing makes hard reading. I mean, if you simply write the first sentence, it comes to your mind and you don't care very much about the connection of the sentences and so on, then easy writing. You, in just, let's say, a couple of hours, you have the paper finished writing. But then it will make the paper hard to read. If it's hard to read, it probably will be rejected because it will not be understood by the referee. So you have to spend time writing. Something that, okay, it's how it is. So you have to spend time to have a good papers. If the readers have to fight through clutter, meaning disorganized, not organized, disorganized sentences and disconnected paragraphs, plenty of typos, so this is called sloppy writing. Some will give up, and then you, the author, will be the greater loser. So this is something important. I mean, maybe I don't care if they want to read the paper. No. If they do not read the paper, you are the main loser because they will not cite it, and you want your work to be cited. So, okay, we have to think when we write, thinking about the reader. The reader should find easy sentences, clear sentences, sentences that are, let's say, followed by figures that clearly support what the sentence says, on all these things. So as the author, your job is to make the reader's job easy. So it should be easy for the reader to read the paper. If it is that the case, then the paper will be read by more people. And also the reader will know that your papers are easy to read, so next time maybe you read the following paper. So key characteristic, we have already told that, is clarity. Okay, and this is a series, again, Twitter. If you go to Twitter, I also recommend you follow this guy. This is Ken Prof. Kramer. It's a very good writer. Also, he's one of the, I think, the people that writes nice papers. So there are many people in my field, many people that in my field that write nice paper, and this is one of them. And see what he says, and this is important because especially for people that starts the PhD. Yeah? The most common writing mistake of many researchers is to write a paper as thought it is a concatenation of 15 group meetings presentation. So this means a lot of data. This is not a good idea to put everything in the paper. You have to choose. In group meetings, it's great to look at every detail. So we look at everything and try to understand everything because you are trying to decide what's important, what needs more scrutiny. But when it comes time to write it up, when you have to write the paper, your job is to spare the reader, again, thinking about the reader. The reader should work as less as possible, should understand everything without putting much effort, a lot of effort. To spare the reader all the work that went into figuring out what was important. You have to thought about all you have done, all data is important, but once you have your data there, you should decide what is important and what not, what is the message, and how to prove the message, to give evidence that this is what you want to tell the reader is true. So the gross gets left behind. What is unimportant is simply leave. And you distill the gold in the most concise, focused way possible, if you think there might be some. So, right? So you decide what is important, and this is what goes to the paper. The rest simply left. You can put some fraction of readership that will care about ancillary details. Hey, there is always supporting information, right? So you decide what is important, and this goes to the paper. The rest goes to the supporting information. Don't put everything in the paper because then nobody will read it. It's too much. But when writing about every sentence, ask yourself, is this critical? Is this sentence, every sentence, so sentence by sentence, is this critical? If it is, you leave it. If not, you delete the sentence. And if the answer is no, delete the sentence. This is the idea. So to make the the life of the reader easy. And this means that the text should be as brief as possible. Sometimes it cannot be brief, but okay. We should try to make it as brief as possible and directly focus to the point. And the rest that is probably is also important, but it goes to the supporting. If someone is interested in details, they will go to the supporting. If not, the paper already contains the main message, the important message. Okay, so we have already commented that scientists must not only do science, right? Not only to go to the laboratory or doing computations, but must write science. So we have to learn how to write. Only after publication of unacquired knowledge becomes scientific knowledge. Okay, this is something that we have already said. The effective communications of scientific research is vital. Is vital to the scientific community and to the scientist's career. So for your career also it's very important to have good writing skills. Making your research results widely known is one of the major requirements for getting promotion and funding. Right? So for your career. So if you if your papers, let's say, are well cited, then it's more easy for you to get, I don't know, let's suppose funding for a postdoc if you want to follow the academic career. So this is, of course, your decision. But in this case, it's important to get the papers well known. For a scientist's career, it is important to have his or her work published in the best journals, and we will talk now about impact factors and quartiles in the area and get them cited. And we will talk about the age and indices. Citation to papers are important because they mean that someone used the work or the ideas to mention in the context of their own work. Okay, so now let's move and let's discuss about this impact factor. So you probably have heard about the impact factor of journals. For sure you have done that. And this is an example. This is one journal, Journal of Physical Chemistry A, again in the field of chemistry, physical chemistry. We'll go then to the easy web of knowledge. I will show you how to check any journal you are interested. And this is how the impact factor is calculated. So you look at the citations in 2017, because, this is the last impact factor that we know, those in 2017. Probably this month, we will already know the impact factors of 2018, but at this moment, only we have the last one that we have is the 2017. So, during the year 2017, how many papers have been cited that were published in 2015 and 2016 in this journal? So this is the number of citations of papers published in 2015, published in 2016, and this is the sum. Right? And then you look at the number of items published in 2015, in 2016, and this is the sum. And then you do the ratio between these two quantities, and this is 2.8. So this is the impact factor of this journal. And the impact factor is the expected impact. So if I publish some paper in this journal, I could expect that during 1 year I will get about 3 citations. This is my expectation because the journal, on average, all these papers get 3 citations every year. This is the expected, but it's not the real impact. The real impact will come later with the number of citations. So after some years, you look how many citations did you get, and this is the real impact of the paper. And maybe the real impact is much larger than the expected impact, or the other way around, it could be. So it is not a direct, of course, correlation. So not necessarily if you publish a paper in a very good journal with a high impact factor, then this paper will be cited many times. Maybe it will not be cited. We don't know. So so we have to differentiate. This impact factor is an expected impact, but the number of citations you really get, this is the real impact. And then once you have the impact factor, you order your journals, right? You order your journals with the impact factor. And the 25% journals that have a larger impact factor, these are first quartile. The next 25%, second quartile. Third quartile and fourth quartile. Some people also look at the decile. So this is 10%. So the 10% of papers that have high impact factor, the highest impact factor, 10% with highest impact factor, these are in the first decile, right? And the second decile and so on. And this is something that, I mean, little by little is being introduced in, for instance, in the ministry, in the calls of the ministry. And okay, I will show you an example now. So we can, I mean, maybe we can go to this example and then also to the, I will show you to the easy web of knowledge. Let me see. Okay, this is this is a call for these Maria de Maeztu and Severo Ochoa centers, and this is for 2014, but it was the same this year, for instance. And if you look, if I put here quartile, so you look, you see, okay, I don't know if you can see them, but okay. So you see as one of the, let's say, the things that they look is that this center or this, that ask for this Severo Ochoa or Maria de Maeztu should have published at least 75% in first quartile. You see here, first quartile. So this is a requirement. If you have not published 75% in first quartile, then you cannot be Maria de Maeztu Center or Severo Ochoa. So this is something that it's something that okay, you have to take into account, because maybe in the next years it will be something that it will be, I mean, you will be asked, how many papers have you published in the first quartile? So every time you publish a paper, if possible, send it to first quartile. If not, okay, it goes to second or third or whatever. But I mean, at least the aim should be try to send everything to first quartile, because it's something that it will be taken into account when evaluating your career. So, and also, if I put decile, there is also some decile. So you have to put the number of papers that, let's say, the center has published in the first decile. So it's something that they also take into account. It's not, there is no here, let's say, a requirement, I don't know, 20% should be first decile. There is nothing like that in this particular case, but they look at this number because it's something that they also consider important. The first decile means that the best journals in a given field. So, okay. So maybe next time if you ask for a postdoc fellowship or something like that, they will look at the quartiles. And it's good for you to know that, if possible, try to publish in journals with high impact factor. It's possible. I mean, it's not always possible, and it should not be an obsession. But if you can try, if you can choose, then better first quartile than another thing. Okay, let me show this. If you go to, let me show this easy web of knowledge. Okay, if you go to the library, there is this. Okay, you can go to the different journals or database. If you go to the database, if you go here to the database, then you can look for different databases. So if you put web of knowledge, okay. So you see here there is this, I hope you can see it, but there is these essential science indicators and this journal citation report. So you go to the journal citation report. So this is the, I'm now showing you how to see if the journal is first quartile or it is not. So just show you. Okay, so there is, okay, so you have to identify yourself. In this case, I think maybe, well, in this connection at least is, I'm connected through the Wi-Fi, so I'm kind of external. Let's say I'm not in the university. I'm kind of external user. So this is why they asked me to identify. But if you use computers from the University of Girona, you enter directly. No problem. From the library, you enter directly here. And you see we have here Web of Science here in this position here. So this is Web of Science. Maybe this is, well, we can go later to this place, but now we are in here, Journal of Citation Report. We are here, Journal Citation Reports. And here you can write a journal name. I will put the same that I have before, but physical chemistry, well, it's here, so I press it here, Journal of Physical Chemistry. This is the journal, and then you will get the data for this journal. And this is, you see the impact factor is here. You see the impact factor this year, 2017. Okay, you have different measures. How was obtained is, you have it here. The most cited papers are here. And if you go to here, you see rank in this position here. Well, I don't know if you can read it, but it is rank here. Maybe I can make it a little bit larger. So if you go to here, rank, then you see here is about the quartile. So this journal, for instance, is second quartile. So you can see the quartile here. And you see there are two categories, physical, chemistry physical, and physics atomic, and molecular and chemical. So a same journal can have different categories. So in one category it could be first quartile, in the other one could be second quartile. In this case, there is second quartile in both cases, but it could happen that it's first quartile in one category and second in the other one. So it's always, in the evaluation process, is taken, let's say, the most favorable to the, let's say, people that is being evaluated. So if here would be first quartile, then this journal is considered first quartile. So there is a doubt, it's always the best option that is taken. But in this particular journal is second quartile. So you can play a little bit around if you want and look for journals that can be of interest for you. You see, I mean, this is telling you that this journal is 69 when you order all the journals of this category, you order them by the impact factor, you have 147 journals, and this one, it occupies the position 69. So this means 69 over 147, and this is 53%. So it's second quartile, but it's not far from becoming a third quartile, according to this one. And for the other one is 14 of 37, and in this case a little bit better, 63%. So, okay. This is something that you have to take into account. Right? All journals have the impact factor, and then they have the quartiles. Okay, so, okay. Maybe, okay, I tell you, you can play a little bit if you want. If you go to this database, you can play with the Web of Science, and then there are several things that you can do there. So let me see, okay. Okay. Let me see. Oh, yeah. So, for instance, you can look all the papers that with a given topic. The one that I told you, aromaticity, right? I can write aromaticity, and if I write aromaticity in that way, the, the database look for all papers that have this word in the title or in the abstract. If I write aromatic, then it looks for aromatic, but also for aromaticity, etc. Everything. So you can also write a title of a paper, you can write the name of an author, and then all publication of this author will come. And anyway, so there are many possibilities that you have. So I recommend you play a little bit with this tool, which is also quite well, it's important to know it. So just if you have time, just play a little bit with all this. And you can add different rows. For instance, you can add here, you have the topic, and then you can say an author, right? You can write here some, I don't know, you can put Lopez, for instance. So then it will look at papers that have this topic, and one of the authors is Lopez. Yeah? So this is, I don't know if there is any paper with these characteristics, but in principle, if there is, the database will. You see, there are six papers with these characteristics. So, okay, anyway. And you see that then the program also gives how many citations have this paper, how many citations have this one, and so on. Anyway, so there are a lot of things that can be obtained, a lot of data that can be obtained from this tool. So I suggest you take your time and, oops, let me see. Okay. So you play a little bit with this tool, which is interesting. Okay, so okay, I have shown you that the importance of this quartile. So in some cases, people look up. One thing that is interesting about the quartiles, I mean, if you compare impact factors of different fields, for instance, in the field of medicine, impact factors are much larger than the ones in mathematics, for instance. But if you look at the first quartiles, then it doesn't matter because, I mean, it's equally difficult to publish in first quartile in medicine and first quartile in mathematics. So it's a better way to compare different fields of research through the quartiles. How many papers in first quartile, second quartile, and so on. Okay. Okay, this is another example. This is about nature. So the impact factor you see is very large, huge, 40. So this means that you expect 40 citations in 1 year if you publish some paper there. In principle, this is the expected citation. But you see then the real is what you find here. So some papers get 600 citations, but there are others that get much less. In fact, out of these 17 or 1800 papers that were published during these 2 years, I think this was in 2015 and 2016, there are more than 600 articles that have only received one citation and published in Nature. In Nature, they get only one citation. And almost 1,300 of these 1,800 that I told you before that have received 5 or fewer citations. So it's not guaranteed that you publish in Nature and you are going to get 40 citations every year. No. In many cases, you get much less. But there are some papers, maybe 10% of these papers and so on, that get a lot of citations because they are very important. So this is the idea. Okay, so this is different journals also. The impact factor that you have. No, this is the number of citations, number of papers. I guess this is the impact factor. The normal one is for 2 years, but also you can define an impact factor for 5 years in the same way. It's more or less the same. And here you get the percentage of papers that have received no citations at all. So 0 citations. And in some cases it reaches 20%. It's quite large. In other cases much less. But so what this means? I mean, it means that the impact factor, I mean, is important, but to evaluate an individual authors, in principle, we should not look at the impact factor. Okay, the individual research performance, I mean, is better, let's say, evaluated if you look at the real citations, not at the expected citations. Expected citation is the impact factor. But okay, so in general, what evaluators does is to look everything. They look first quartile, second quartile, so on. They look impact factors. but also they look the real situations. Everything is considered before taking a decision of giving the fellowship to one or another. And this is what is called DORA assessment, also the San Francisco Declaration on Research Assessment. So this is the DORA. And some universities have already signed this declaration. In our university, not, but okay, I don't know if we have to do that. But they say the impact factor must not be used as a surrogate measure of the quality of individual research articles to assess an individual scientist's contributions or hiring, promotion, or funding decisions. So when evaluating people, we should not look at the impact factors. We should look every paper, let's say. Any evaluation system in which the mere number of researchers or publication increases his/her score creates a strong disincentive to pursue risky and potentially groundbreaking work. So this is something that it was discussed in these editorials. So this is a problem. It's now we are evaluating people usually from the number of publications and the impact factor of the publications. And what this creates is disincentive to pursue risky and potentially groundbreaking work. Because sometimes work that is, let's say, more routine work, it's okay, you can publish it and without less work, that some work that is more risky and needs more time, and probably the publication will not be in high impact factor journals. So this is a problem that at this moment we have in science, I think. There are some problems around these impact factors and all these kind of things. So impact factors was initially only, let's say, taken into account in libraries. So people in libraries, they decided which journals they buy or not, depending on the impact factor. And this was the idea of the impact factor. But then the impact factor goes to these evaluation processes. And now people is also looking at the impact factors when evaluating curriculum and this kind of things. Okay, and this is a nice story. If you go here, okay, I will just briefly comment on this fact, but you can go here and read it in more detail. So this was one paper that was published, if I remember, this was published in 2000. Not see here, but anyway, here it's in 2008. So one paper that was published in this journal. So this journal is a journal that has not very high impact factor. You see 1 point something. It's relatively low. Yeah? So probably this is third quartile or even fourth quartile. I don't know. And some people publish a review here, and it's a program that is called HL or something like that. So it's about crystallography, diffraction, X-ray diffraction. And because the review was published here, so many people use this program for X-ray structure, to determine the X-ray structure. Because the review was published here, so people started to cite this work, and you see these 2 years, the 2 years after the publication of this one, so the impact factor raised to almost 50. So from 1, almost 50. 50 is more than Nature and Science. It was the highest impact factor during these 2 years was for this journal, which is Acta Crystallographica Section A. During 2 years, it was the highest journal possible with impact, the highest impact factor of all journals in science. And then after this year, because in this year, you look at the papers that were published 2 years ago. So again, it reduces to 1 point something. So this is something that could happen. It can happen. There are some strange cases with this impact factor. Okay, there are also some unethical behaviors behind these impact factors. You can maybe read them here if you want. You can go here and you will see. And there is some comment here about the problems that are related to impact factors. So the impact factors are used and we have to take them into account because it's something that is important for our career. But okay, there are a lot of problems or some problems related to the use of these impact factors. Okay, and then maybe you have heard about that, this H index. So this is the Hirsch index that was discovered by Hirsch. well, discovered, I mean, proposed by Hirsch. And apparently, this was a professor that has to evaluate a number of curriculum, relatively large number of curriculum. And he decided to use this H index to make a first, let's say, scanning of the different curriculum. And just instead of looking at, I don't know, more than 100 curricula, then he chose 10 or something like that, and these were, um, were looked in more detail. And what is the H index? So basically you have, let's say, you can have an H index for a scientist, but also for a group of scientists. So for a research group, for the university, our university also has an H index. For a country, so you can have H index for, I mean, people or group of people. Yeah? And the idea is you have, for instance, all papers published by a given scientist with the citations, right? And you put the most cited here, then the next one, and so on and so on. And this, okay, there is here more or less the x equal y, let's say, line, right? And okay, this point, so let's say this point, for instance, this number here could be 6 and this number could be 4. Yeah? So this means that this guy has 5 papers with more than 5 citations. So this index H for this researcher is 5. Yeah? So you have to look how many papers you have with more than a number of citations. Yeah? So you have 20 papers with more than 20 citations, your index H is 20, right? So this is the idea of this age index. Of course, it grows with the age, yeah? So it cannot be compared the age index of a young people with old people. Yeah? But okay, with people of the same age, more or less you can compare the age index if they are in the same field. Also, different fields have very different age indexes. Yeah? For instance, in mathematics, they have the number of citations is very low, yeah? So the H index is low. So in mathematics, maybe an H index of 20 is already a lot. Yeah? In chemistry, maybe you have, I mean, maybe 40 or 50 should be is something quite frequent, let's say. Yeah? So it's dependent on the area of research. So if there are more scientists in the area, you have more papers. If you have more papers, there are more citations, so the index H increases. So it cannot be compared between science of different areas. Okay, there are tricks to increase it, but okay. Okay, there is a relationship between the total number of citations and H index. Someone described this relationship, which is approximate, of course. You have here an H index predictor. So from the papers that have published till up to now, you can predict in the following years which will be your H index. Okay, and if you want to see why I love the H index, someone wrote something about this in this paper here. Right? But okay, I leave it up to you if you want to read it. As I told you, this H index does not allow to compare scientists of different ages. So for this, it's better to go to the M index. And M index is the H index divided by the number of years since the publication of the first article. So you have here the H index for the blue scientist, and you see that it reaches 12, right? And because the first paper was published in 1989 and the last one here is in 2011, so this is 22 years. So the M index is 12, number of papers. Oh, sorry, H index divided by the number of years, I mean, from the first paper. So it's 0.6, right? So this, in red, it has the largest H index, but this was obtained in 15 years, so 1.1. And this in green, it has been, the H index of 15 was been obtained in 7 years, so it's 2.1. So if we compare these three scientists, we reach the conclusion that the one in green is the one that is progressing the better, is doing the best or the better. So, okay, you have more or less here. So the less than 1 is average, with 1 and 2 above average, 2 and 3 excellent, and more than 3 stellar. So this is more or less a classification, just to have an idea about this. But also it depends on the field. As I told you, in mathematics, this number should be much lower. Maybe stellar is already with 2 or even less. Okay, and this is in Stanford, also discussing about this impact factor in age index and all these things. They say, when they hire people in Stanford, in the chemistry department, we do not look into how much funding the candidate has brought to the university. In some cases, this is something that is taken into account because it's important. In the form of grants. We do not count the number of published papers. Doesn't matter how many papers. We also do not rank publication according to authorship order. If it has been first order, second order, or first author, second author, or last author, or whatever. We do not use some elaborate algorithm that weights publications in journals according to the impact factor of the journal. They do not consider impact factor. We seldom discuss age index metrics, which aim to measure the impact of a researcher publication. We simply ask outside experts, as well as our tenured faculty members, whether a candidate has significantly changed how we understand chemistry. If he has done that, then we hire them. It doesn't matter how many papers, impact factors, age index, whatever. Okay, this is probably a good option, but this is something that they can do in Stanford, but we cannot do it here probably. Because we will not hire anyone, maybe, I don't know. I mean, these people that makes significant contributions to chemistry, they go to these kind of universities. Okay. But still, it's interesting to read this reflection, these ideas. This is what, it should be that way, that promotion should be on the basis of how you have contributed to, in this case, understand chemistry or biology or whatever. But okay, it's very difficult, and at the end, usually the impact factor, number of citations, this is something that is important for the promotion. And this is another recent paper in Nature Worldview. So this is some discussion about, again, all these impact factors and all these kind of things. And this is the guy that wrote that. We are told that the journal impact factor should no longer be used, but not told what to use instead. And this is a problem. Okay, as evaluators, sometimes the scientists also act as evaluators. They have to have some, let's say, tools in order to make the list of priority of the different fellowships or different whatever, or projects or whatever. Okay, I mean, and this is something that is quite easy, to look at the quartiles, the deciles, these kind of things. If we cannot use that, what we should use? I mean, it's very difficult. We should read every paper. It's impossible because some of the researchers, they have maybe 200 papers. We cannot read everything. So it's, it's this. So the problem of evaluating research is a big problem, is there, and okay, it's not solved yet. And in the meantime, they are using people use impact factors to evaluate. So this is something that you should keep in mind. Try to put your papers in first quartile if possible. Okay, so now let's go here, and okay, now we have already the work in the laboratory finish, for instance, and when we should start writing the paper. And here is said, as soon as possible after the main body of the work is completed. The work must be fresh in your mind. So this is, I mean, it's better once you finish your work in the lab, you start writing the paper. Do not wait for several months because now you have the work fresh in your mind. Is a good moment. And also, when the answer to this question is yes, the question is the following one: do we have important new molecules, methods, procedures, physical insights to report? It's something that we have to communicate, that is important to communicate. Then if the answer is yes, then we can go and start writing the paper. Of course, when we decide what to study, the reason for studying a system cannot be because it has not been studied before. This is not a good, let's say, um, a good reason to start our work. We have to start our work because there is a gap in the knowledge, there is something that we don't know, and we want to fill this gap. Okay, maybe you can also, if you have time, maybe you can look at here. What does important new physical insights mean? Tips for writing better papers. So maybe you can go here. But it's something that new physical insights, it depends. In some cases, there are some fields that are relatively immature, and in this case, everything is almost new, so everything is new physical insights. In other cases, new physical insights need to be assessed in the context of what has already been published. So maybe, I don't know. So it depends on the maturity of the field. The meaning of new physical insights could be different. But okay. I refer to this work here. This is an editorial, I think, in Journal of Physical Chemistry Letters, again, about the discussion of what means new physical insights. But okay, we have to write the paper, we have something to communicate, some message to the reader. If not, better to not write the paper. I mean, it will not work. So this question should be, the answer to this question should be yes. If it is yes, then we can start. When I start writing, as soon as you have clearly defined it, also, the answer to these questions should be positive. What is your point? We have, as I told you, we have to have a message to deliver to the reader. So, and this is our point. And all the paper should be focused to this point. Then we have to identify the key story points, and this means everything that supports your message. Maybe it could be a table, figure, everything that supports the conclusion, then this should be identified, and you have to have it ready. So what is the main thing you want your potential reader to remember? This is again the message. The message that we want to deliver to the readers. And this is something that it happens always. Cheaty first draft. So the first draft is never a good one. All good writers write them. It doesn't matter if you are good or not, or bad writers, you will write usually a first draft that is not excellent. That is how they end up with good second draft and terrific third draft. So we start with a first draft that is not very good, probably, but then, okay, you modify it, you read it, you look at the structure, try to connect everything, support all message that you want to give. And in that way, you are creating a better second draft and then a terrific third draft. And this is an idea from from Anne Lamott. It was one of the authors of these books that I show you in the first slide. So the second draft should be the first draft minus 10%. It's the idea of reducing the number of sentences, and making the paper shorter, brief. Every message, the paper brevity is important. So this is the idea. So the first draft should be, the second draft, it's a good idea to think that the second draft should be something shorter than the first one. The first one is maybe a little bit longer, and then we make it shorter and more focused to the point. This is the idea. Okay. At least is what this Anne Lamott suggests, and I think it's a good idea. And we have to write. Use the best time of the day. Yeah, it's okay. It's important to be concentrated. Try to nobody should interrupt you if possible. Try to find a couple of hours or whatever without interruption, so you can be concentrated and doing this work. It's difficult. It takes time and to construct the different sentences, make everything connected, easy to read. All these things takes time. How much to publish? Again, you start your career more or less now, some of you. So you have to publish a lot, you have to publish less, but you publish. Okay, so if you look at this paper here, this is what they say. Okay, they have made, let's say, a study about that. They have looked authors that publish a lot of papers, others that publish less, and they have concluded that more papers, better papers, the curious correlation of quality and quantity in academic publishing. So it seems that publishing more papers, you end with publishing better papers. Well, this is what, at least this is what these people tells in this um, in this in this article. So why? They think about possible explanation of that. First explanation they say is writing both improve and create ideas. So you start writing, because you write, you have to read other previous authors and you get new ideas. So you get new ideas, so then you start making a new project and you write the project and so on. So this kind of synergy between um, the writing the papers and getting new ideas. Then they say, and probably this is also important, early quality or quantity attracts resources that foster both. So let's suppose that now you are doing your PhD, and during your PhD you publish, I don't know, a number of papers, whatever. If this number is relatively large, then you have a lot of possibilities to get a postdoc fellowship in the coming years. If the number is low, you get probably the possibilities that you get a fellowship are lower. And this is the idea. So if we have early, from the beginning, quality or quantity of both, then you can attract resources that helps to continue the career, foster both, quality and quantity. And quantity attracts positive attention from peers. That's also true. I mean, there is an author, I mean, maybe you know some case, but in my case, I remember one author that is called Álvaro Muñoz, I think, and he started to publish, I don't know, every 2 weeks or 3 weeks, a paper appears of this guy, and at the end, okay, I had the attraction to know what is he doing, so I read some of the papers. So it's this idea that, okay, if you see a name several times, in few months or few weeks, at the end okay, what is this guy doing? And then you look at the papers, and so it's a way to attract positive attention from peers. And this is called Matthew's effect. Matthew's effect, you know, this is in the Bible. This is Matthew's Gospel, chapter 25, verse this one. And basically, it says, whoever has will give him more, they will have an abundance. Whoever does not have, even what they have, they will be taken from them. Okay, it's this, you know, this Matthew verse or Gospel. Okay, so there is here another paper by a guy that this is in Spanish. It was published in Anales de Química. And okay, it's a professor that now it's 80 something, so it's an old professor. And he has published more than 1,000 papers. So many papers. I mean, there are few people that reach these numbers. And he was fed up of people telling him, you are publishing too much. So and he wrote this paper. And okay, he did say, okay, at the end is a personal election. So if you want, let's say, as an author, you can maximize the sum of number of papers multiplied by impact factor. So I don't have I can write it here, but anyway, no, there is nothing. No, there is not a board. Anyway, so this is impact factor by number of papers and the sum. You can maximize this function. By maximizing this function, maybe you are publishing a lot of papers. You can, if you want, you can maximize the number of papers multiplied by the impact factor square. Right? In this case, you are now more in the idea of selecting only publishing in good journals, let's say. Or if you want, you can maximize the function of number of papers multiplied by impact factor cube. Right? And these people are the people that only publish in very good journals. They publish few papers, but in very good journals. This is a personal decision, he says. You decide. You as an author, maybe not during the PhD, but at least during your career, you decide, okay, I will only publish very good papers. I don't want to publish in bad journals. Well, this is your decision. But then, this is, you can be in that situation here. And you put a lot of emphasis in quality of the papers. So you publish very few papers. What is the problem here, in my opinion, is people that is working with supervisors that are in this region here, they publish very few papers, maybe one paper during the PhD, or even no papers, or not more than two. So these people then maybe they could have problems to continue the career, the scientific career. And on the other hand, you can be in that position, quantity emphasis, right? But then the quality, normally the quality of the papers, if you put more emphasis in the quantity, is not that good. And also, if you put a lot of emphasis in quantity, you see that you have, this is, let me see, yeah, you see, this is, I mean, you, you, let's say, you are lowering your ethical standards in some cases because, okay, you are trying to publish so large quantity, then, okay, you can make errors or this kind of things. So let's say there is a problem of, probably there are ethical problems or at least errors in the papers. So it's not, also it's not very good to be in this position. And they say that the optimum is like that. But okay, it's very difficult to find the optimum. So it depends, it's a decision, it's your decision. You decide whether you want to be. But I would say that both in this position and this, they are problematic. Okay, so this is this picture comes from this article here. If you want to read it, okay, there are some comments about the idea of production. If we should produce a lot of papers or just only few of them, but in very good journals. So, okay, this is something that you at the end you decide what you prefer to do. And where to publish? Okay, we have been discussing this for all for a long time now. And okay, the idea is that in journals where it can be found by the broadest, most relevant audience. So let's suppose you have a paper that is very specialized, so it's better probably to send the paper to a specialized journal. These specialized versus generalized journals. If you can choose, better you choose high impact factor journals. Okay, so maybe the first submission is to a high impact factor journal. Then if it comes a rejection, okay, then you lower the quality of the journal. Maybe you submit the journal to a lowest journal with a lower impact factor and so on. But at least first quartile, first try should be in a journal first quartile. Then you will see. You have to take into account the visibility of the journals. So some of them are open access. So open access probably is good because there are people, let's suppose in Africa or in other parts of the world that can have access to these papers, and when they publish a paper, they will cite research that has been read by them, and this is something that allows to any people in any part of the world to read what has been published. So open access is not a bad idea. The point is that at least in chemistry, open access journals are usually journals that they do not belong to the first quartile journals. I don't know in your specialty, maybe in biology or biomedicine, this is different. But at least now, at this moment, in chemistry, open access journals in first quartile, there are a few of them. So they should be available in universities, research institutions, corporations, and including the major research database, the Web of Science, the database that I showed you before, the Scopus, SciFinder, PubMed, so on. Okay, so we choose the journal by the impact factor and the visibility. Should be read by our peers. Okay, this is just a joke. Someone that they decided to make its own journal and they call Cell Nature and Science. So I publish everything. I publish extensively in Cell Nature and Science. This is because the name is the name of the journal is that way, no, not because he reaches these well-known journals, Cell Nature and Science. And how to publish? I mean, now we have our results, we have our um, work in the laboratory already done, and we want to write the paper. How we should write the paper, and we should write the paper as a storytelling, as a story, like, I don't know, as some story that we explain to the children when they are young children. So it has the introduction or the introduction, the middle, and the end. Yeah? This kind of idea that should be you should publish the story of your discovery. And like everything, storytelling has some rules. We'll see now. If you want to do it well, if you want to explain the story of your discovery well, you have to do it in that way, as storytelling. A paper has to tell a good story to capture the audience attention, but without using suspense or humor sense. We are not novelists. We are writing science. So because of that, there is no suspense from the very beginning. In the abstract already, we told what is the main result. No suspense at all. And okay, probably avoid humor sense also. So it's science, so some serious thing. And the paragraph should be ordered to narrate the story. You have something to explain to the reader, and you order the paragraph to explain this story, not in the same order as the experiments were done. So maybe you start with the last experiment, not with the first experiment. I don't know. You forget about the order that you have got your data. This is something that is not important. You have to think about what is your message and to explain a story following an order that should not be um, the order where the experiments were done. Our ultimate goal is not to present new results, it's the understanding we derive from them. The flow of ideas in good scientific papers is like that. This is the discovery of the DNA, the structure of the DNA. So this is the picture that Rosalind Franklin got from an X-ray structure of DNA. So from here, this is the data. This is the data. And this is the information that this picture contains. So people that know about X-ray know that these spots here, this means that you have a double helix. This is something that I don't know how they know, but okay, it's something that it was already known. So from this data, we get this information. So we have a double helix, and now they know also the composition of this DNA. So they put the nitrogenate bases and phosphates and everything, they put in a model just to create a double helix. And this was the work of Watson and Crick. So this is what they get new knowledge by doing so. How this double helix was connected. It was connected through these hydrogen bonds and all these things. And they even did one step further, which is the, the, the farthest that you can reach is this understanding. So from the double helix, in the paper, in fact, they already propose how duplication of the DNA occurs. And this is, you see, this is how it goes. There is, well, I don't know exactly who opens the double helix, but anyway, you know that it's open, and then the complementary base come, and then you have two double helix from the place where we have only one. So this is how the DNA is replicated. So you see from the data, you get some information. From the information, you get some knowledge, new knowledge. And from this knowledge, in some cases, you can get new understanding. If your paper goes through all these, let's say, steps, then it's perfect. In some cases, you are here. Yeah? Maybe you can publish a paper with this data and information. It's enough. Maybe it's enough. Yeah, but the paper is not as good as if you get some new knowledge. Yeah, then the paper is much better. And if you get understanding, then the paper is perfect. Yeah? So this is the flow of ideas in good scientific papers. Yeah? They have data, information, knowledge, and understanding. Okay, this is more or less the same, data, information, knowledge, and then this is separated, and understanding is separated into insight and wisdom. But anyway. And this is another paper that was recent editorial. Well, in this case, is in particular for computational papers, but okay, the ideas are the same for any paper, I would say. Yeah? This is for chemistry, computational chemistry papers, but in general, if you read this editorial, you will see that it's useful for any field. And you see, more important, keep it short. We have talked about the brevity. The paper, the shorter, the better, in principle. You probably would not be excited to read 50 pages about experiments that fail. So the experiments that fails, they should go to the supporting information. Do not expect that an experimentalist wants to read 50 pages about computation that are not relevant. So the same, if you have computational results that are not relevant, this to the supporting information. For non-preferred mechanisms, refer briefly to the results, but place the details in the supporting information. Okay. This is about reactions in chemistry. You can have different pathways, different mechanisms, reaction mechanisms. In some cases, computationally, you study all possibilities, but there is only one in general that explains experimental results. So this means that in your paper, you should explain only this, the one that explains experimental results. And the rest, they should go to the supporting information. The reader that is interested, they will go to the supporting information and look at this information. And the rest, for the rest, probably doesn't matter. What it doesn't explain the experimental facts is something that is not important. This is the idea. So just to distill what is important. Maybe you have a lot of information, but we should select what is really important for the reader. We have to think about the reader. Okay, and this is science writing as storytelling. Identify the key points. And the key points are this OCAR, if you want, mnemotechnic rule. So all the stories have a beginning, a middle, and the end. If you think about this little red Riding Hood, so la Caperucita or Capucheta. So it has a beginning, right? The story has a beginning, and there is the little red Riding Hood that wants to bring something to eat to the grandmother, and there is the wolf there, and so on. This is the beginning, right? Then there is a middle, and the middle is what it happens. So it happens that the wolf lies, or tells the Red Riding Hood that she has to go through a path that is longer, and he goes faster to the place where the grandmother lives, and then the wolf eats the grandmother, and he puts in okay, all these stories, and at the end there is the end, which the end usually in these stories for children is happy, so so they take the wolf and they put the wolf in the lake or something like that with the stones in the stomach and this kind of things. Okay, so this is beginning, middle, end. So our paper should be like that. Now we have an introduction, a beginning, which is the combination of this opening and challenge. You see, this is the beginning. So opening, what is the problem? So why am I studying? I'm doing this study. Why I'm doing this research? There is a problem. I want to know something that is not known till now, right? So we have to explain what is the problem. And so in this part, we identify the larger problem to which you are contributing and make it clear why it's important in connection with previous knowledge. This is important in connection with previous knowledge. So this means that we have to read all that has been published till now about this problem. And we have to make it clear. Okay, all these authors have studied this, and at this point now I am studying this gap of knowledge, this something that is not known yet. This is my contribution. Should be clear in this opening. So identify the knowledge gap you try to fill. This should be made clear, and then there is a challenge. What is your specific question or hypothesis? What do you want to prove? Maybe you want to prove, I don't know, that some gene is important for cancer. Some question you have, some question you want to prove something. You have a question to answer, and this is the challenge. Make the question clear is more important than indicate the objective. So the question is very important. In the introduction, it should be clear why you are doing this research. What has been done till now, and what you want to know, and why you are doing this research. What is the answer that you want to answer, the question that you want to answer. And then this, you see, opening, challenging, this is for the storytelling. For all storytelling, you have an introduction, let's say, which is these two parts. And then there is the action. And this action, what are the key results of your work? Identify this in a short list. There should be no more than 3 points. Wow. So this, so the key results are the results that support your main message. So you have something to tell to the reader, and then you have, I don't know, table with numbers or whatever that supports this message. And this is what you have to put here. So these are the key results. And finally, the resolution. What is the conclusion? Use the results from section 3 to answer question 2, challenge, to explain the problem identified in 1. So this is what we have to do. Okay, so not now, but maybe let me just finish the next slide, and then I will ask you to think about this part, which is write a short article, so just describing your research following in 1 to 4. So you have to write a communication, right? I ask you to do so. So this should help you to write this communication. I mean, when I ask you to write a communication, I don't mind if the research is corrected or has been, or is invented. I mean, you can invent the results if you want. I mean, I don't mind about the results itself, let's say, themselves. But what I will look is about the structure of the paper and the flow of ideas and these kind of things, not about the results itself. So if you have the results, good. You start writing the paper with your real results. If you don't have results, you use some invented results. It doesn't matter. But think about the paper the communication that you want to write, and I will ask you in 5 minutes to do so. So to try to describe what is the problem in 1 sentence, just 1 sentence. What is the problem? So 1 sentence for 1. What is the specific question that you want to answer? So 1 sentence for 2. What are the key results? And what is the main conclusion? So it will be a good starting point for your communication later. So I will give you 10 minutes to do so. I mean, if you want to, I mean, you can do it at home if you want. It's not that you have to do it now, but okay, I will not, you should not, I mean, I will not ask for giving me, let's say, a paper with this discussion. It's simply an exercise for you. It's not for me. I will only correct the communication at the end. This is an exercise for you to think about what you have to do to help you to do the communication at the end. The one that you have this deadline of 14 June. Science writing as a storytelling. We are still with this idea of storytelling. Good science writers make sticky papers. What means sticky? Sticky is something that it means that you cannot, you have to read it. I mean, you cannot finish, you cannot leave the paper in the middle because it's so good that you have to finish it. It's like a novel. Sometimes the novel is so good that you cannot go to sleep without reading everything. So this is the idea. There are papers that are so good that they are sticky papers. You have to read the papers at the end. You cannot go to sleep without finishing. And these people, they identified the factors that make a story sticky. And this is the mnemotechnic word, success. Meaning, S meaning simple. For instance, natural selection. So it's a very simple idea, but very powerful, right? Only survive those that are stronger. That are strong, the strongest, let's say. This is natural selection, simple idea. Unexpected, right? So most papers are forgettable because they are incremental. Incremental is simply, I don't know, in chemistry would be, let's suppose you have a reaction that has been done thousands of times and you do one more with a different molecule, but it's simply that this molecule was not, this reaction was not done with this molecule, so they are really new results, but are not especially interesting because, okay, it's simply one molecule more. These are incremental. So incremental is not that the paper is bad, but okay, in principle, it's not especially, you will not, with incremental results, you will not get a sticky paper. It's the unexpected ones that produce sticky papers. Concrete, stay focused to the point. So we have a message and everything is related to this message. The introduction, the message is clear. In the tables and the figures all go to support the message. They are put there in order to support the message. Credible. Credible means that new ideas are credible if they grow from previous work, expanding them to past from future. This is, you get the paper credible in the introduction. Right? You have an introduction and you review all previous paper about that has been done related to this work. So then it is clear that you know what has been done till now and what is going to be, and okay, what is your contribution. So this makes the paper credible. So this is something, in principle, that could be done for any paper to make it them credible. Something that we have to do in the introduction. Emotional, need to engage readers' curiosity by trying to answer a good question. The question is fundamental. If you have a good question, then, I mean, you attract the attention. There is a, I don't know, if there is a good question, I mean, the reader, okay, gets attracted usually. It's the way to attract the people to engage reader curiosity by asking a good question. So this is why it's important. This is the emotional and the stories. All stories have a beginning, a middle, and an end. So it should be tell like a story. This is the introduction, results and discussion and conclusion. This is how it should be. And this is a paper that they, I don't know how, but they compare different texts, and in some cases they have a narrative style. A narrative style means storytelling. So beginning, middle, and end, and others that are more expository. So, okay, we found this and that, but it's not this idea of middle, beginning, middle, and end. So in a narrative style increases that take and influence of articles. So it seems that well, I don't know how they do it, but there is computational linguistics, so something like that. They use a kind of algorithms or something like that to conclude that some papers have more narrative style, others have more expository style. And those with narrative style, and those that explain stories, are those that are more influential to other people. Okay, and okay, this is just to tell you that in some cases now, so some years ago it was just the paper, now you have some journals publish also videos, I mean, if you want to publish in some journals like Nature or Science, which is very difficult, you have to include artistically attractive skills, color graphics, all these kind of things. This is something that, okay. But not in all journals you have to have good figures, but so artistically attractive probably is not necessary, I would say. Okay, so I finish here. So this is, you see this symbol here is just if you want to laugh a little bit. So this is interesting stories. This is called phdcomics.com. I know if you go to this to this website. There are a lot of stories. And, okay, pick some of them related to writing papers, so you can maybe have a look if you want. And okay, we can finish today here. And if you want now, you can use 10 minutes to try to write one sentence for each point. So this may help to write the communication later. So if you want to use, but also if you want, we can stop here and okay, you can do it at home as you like. But if you want to use these 10 minutes, it's up to you. Okay, so thank you. We will meet again next Wednesday. So I don't know if you have this assistance, this sheet with the assistance control. Yeah. Everyone has signed here. Not this week. Before you leave. So you mean probably this slide? Okay, if you go to your Moodle platform, go to this course, and you will see that there is a place where you can upload your communication there.
Are we automatically added to the class if we're registered in Moodle?
Sorry?
Are we automatically added to the class if we're registered?
Yeah, yeah. If you are registered, you will be there. Yeah, yeah. The list of participants. I'm sure that you are there. I can maybe we can check it, but in principle, let's suppose if I go to the Moodle, sí. Tema de tribunal de tesis. Ah, sí, és la Politècnica. A la Politècnica, a la sala amfiteatre, que és la Politècnica, crec que és la 2. Sí, la coneixes, Pau? Allà. Es veien de marrons. Déu de mi. So if you go here, I mean, if I go to this, then I can
I think it's disconnected.
participants. Yeah, it's here. So you see, you are. I don't know your name, but in principle, you should be here. Right. So all these people is there. So I guess you are there. I guess.
I will check.
But the communication, like when you give communication in a college or...
No, like a paper. A paper, but a short paper. So it should be introduction, methods, and all these kind of things. So you will see here. Let me see. Yeah, you see. I mean, these are. Oh no, sorry. Sorry. No. So if you see here, there is a slide used in the course. So this is simply the slide. It's a PDF file if you want. You can download. There is a template for the communication. This is just a possible template. You can use others. This is a template for a journal that is called Chemical Communications. Okay? You can use this, and then you can write in that way. If you want to use other templates, you can use it. And then submit the communication. So you put it there, okay, and you upload the communication there, and then I will recite it, and I will make the corrections.
So there will be feedback on there will be a feedback.
There will be a feedback, but okay, do not expect a very long feedback, but some comments that will be there. In principle, I mean, there is pass and no pass, so it's simple. I will check that you have done this 80% assistance, and then you have done some communication. It's not very good, it doesn't matter. I don't know, the better the best, right? The better communication, the more happy. But I understand that. Okay, it's not, the idea is not to.
I beginning this year my doctorate,
Sí.
but I don't do results.
Okay, but you can invent it.
Okay.
I mean, it's not. I'm not going to judge your scientific results. I'm going to judge
The structure.
the structure. If you have a good question, you have right.
Okay. Thank you very much.
Okay.
The question I have is is it possible for the evaluation to submit some sort of part of the published paper?
In principle,
Because
I mean, I don't know what you mean by a part. I mean, if it's a paragraph, it would be probably okay. But if it's
because I already have 6 published, you know.
yeah.
Okay.
So yeah. Okay.
So I mean, for me, it
So
would be
maybe,
nice
I
to
don't
know your feedback about.
Let's suppose that you have a full paper.
Okay.
So you can take this full paper and make a communication. This would be acceptable for me.
Like, how could you say it again?
Yeah. Let's suppose you have a full paper, 8 pages, 9, or 10, whatever. Maybe you can select a part of the results, or
Yeah. This was the thing I was trying to say.
This is fine. This is fine.
I mean, it would be nice.
The problem is, I mean, if it's exactly the same that you have already done, okay, this problem is not the idea.
Yeah.
But if you take something that you have already done in some format, it's a full paper, and then you make it a communication from that out of that, this is okay. Okay.
Thank you.
Bye.
See you. Have a good day.
Darek. So how are you doing?
Very nice. I really like it's a lot of basic information that I didn't know about. So
I'm happy that you learned
I'm
something. Yeah.
unhappy because my M index is 1.6.
Ah, very good. It's excellent.
No, it's
1.6.
1.6. It's not excellent.
It's above average.
Above. So
But
I didn't follow the link about tricks how to increase the age index. So I will do it.
Yeah, but okay. Yeah, you will see that in some cases it's like cheating a little bit, I think.
No, of course I'm not thinking about any, ethics issues, etc.
Because
I'm
they,
thinking
for
about-
instance, they say, let's suppose that you have age 15, and then the 16, you have 15 papers to this paper. What you can do is to cite your own paper to get it 16, these kind of things. But okay.
Yes.
I mean, this is
This is
not a
something
good
that
idea.
I'm actually doing because I have a lot of papers, very specialized journals, and sometimes even in the recent paper I added some information that those techniques of projecting are, they follow from some information theoretical analysis, and then I put them in the presentation.
Okay, yeah, this is
The trick.
yeah, and this but this is good because then some people will go there and look at these papers.
Yes, but now I have a lot of interesting ideas, projects with you, but I can't change the past.
No,
I have
no, the past is
something.
already there. No, and okay, and I will say, in your case, Derek, I don't know if this is true or not, but it seems to me that you have more or less your career quite well, let's say, defined, because you told me that when you will come back to Poland in principle, you will have a permanent position there or found.
Yes, permanent position, and the salary will be exactly twice what I got before I.
Okay, so okay.
Went to this.
So in this case, I mean, you should not be, I would say, too much worry about this. Well, I mean, of course, if you can improve your age index or whatever, yeah, this is good for sure. But I mean, you are not so pressed as probably people that start from zero. And
I have a lot of luck because you found me, you found the paper, you were a reviewer of my project, so, and Professor Krygowski also did. So this is a luck.
yeah,
Good
yeah.
luck. Good luck.
Yeah, Marek, Professor Krygowski, I mean, he's very kind with all young researchers in Poland. He's trying to promote you.
Yes, I know that. I'm really happy that I will meet him in June in this conference that we are attending together with Julia, and then in Warsaw